Okay, so thank you very much then. So this is the introduction for the Confidential 6G project, which is working on confidential computing and privacy preserving technologies for 6G. As already introduced, my name is Vera Stavroulaki. I'm with Wings ICT Solutions and I am the project coordinator. So starting with the project vision, 6G infrastructures must ensure reliability, trust and resilience on a globally connected continuum of heterogeneous environments, supported by the convergence of networks and IT systems to enable new future digital services. The substantial increase of coverage and network heterogeneity raises severe concerns that security and privacy in 6G can be worse than in previous generations. A 6G network should be a deep integration of emerging artificial intelligence tools, new hardware components and accelerators, compute and networking functions, Internet of Things and edge nodes. So obviously contemporary security solutions need to be enhanced. And Confidential 6G emphasizes on privacy preservation and security of sensitive data by focusing on protection of data in use. This is an unsolved issue with solutions just emerging with confidential computing. In transit, where Confidential 6G aims to enhance communication protection with post-quantum cryptography, blockchain technologies, and secure data access control and traceability platforms. And at the edge, where the aim is to work on specifying the post-quantum cryptographic approach most appropriate to cater for constrained edge and Internet of Things devices. Additionally, in order to avoid data movement from the edge and increase trust and security, federated artificial intelligence and machine learning will be addressed. So in this direction, Confidential 6G will base its research on 3 pillars, which include post-quantum cryptography, confidential computing, and confidential networking or confidential communication. Some key facts about the project. It was submitted under the topic stream D0104 on secure service development and smart security. It started, of course, at the beginning of this year and has a duration of 3 years. The total budget is roughly 5.3 million euros. As already introduced, I'm the project coordinator and the technical manager is Drasko Draskovic from Nokia Network France. Confidential 6G comprises 13 partners from 9 countries, 8 EU member states and 1 non-EU country. The consortium represents a blend of expertise united in the ambition to contribute to a European secure framework for 6G cloud and edge. Confidential 6G combines the expertise from 3 major industry partners, Nokia Networks France, Nokia Germany and Telefonica, 3 SMEs and 7 academic and research organizations. The consortium has been set up to bring together researchers with strong expertise in cryptography, distributed systems, networking, machine learning, distributed ledger technologies, multi-party computations, and orchestration. So as already mentioned, Confidential 6G will research post-quantum cryptography to create tools, libraries, SDKs and other artifacts needed for future 6G technologies. For this, the objectives listed here will be pursued, and the aim is really to advance the state of the art in the 3 domains or 3 pillars mentioned before. Here we can see in a bit more detail the Confidential 6G research areas and the main building blocks that can map onto a 6G security architecture. So from bottom up, these include the confidential toolkit or cryptographic enablers layer. This covers quantum-safe cryptographic schemes, blockchain zero-knowledge proof and other cryptography, and post-quantum transport layer security and homomorphic encryption cryptographic schemes. So these cover, in a sense, network access security, network domain security, and application domain security. The confidential computing layer covers hardware trusted execution environment encryption enablement and hardware issued remote attestations, end-to-end encryption of the compute workloads and low-level support for trusted execution environments, and transport layer security within trusted execution environments, secure enclaves, fully homomorphic encryption, and secure multi-party computation. And then we have the confidential networking layer, which covers post-quantum transport layer security and other networking protocols implementation, end-to-end encryption, quantum-safe blockchain consensus, and blockchain confidentiality implementations, and authentication via decentralized identifiers, verifiable credentials, as well as secure data sharing using distributed ledger technologies. On top of these layers, CONFIDENTIAL6G builds a practical implementation of the developed technologies, verifying them through 3 industrial use cases. Of course, the project also includes activities for the coordination and management of the project to ensure efficient, smooth and timely execution of all project activities, as well as standardization, dissemination and exploitation activities for ensuring the impact of the project. As mentioned, CONFIDENTIAL6G will test and validate the developed solutions in 3 use cases. These include predictive maintenance for airline consortium, a mitigation of internal threats for telecom cloud providers, and intelligent connected vehicle for mission critical services and over-the-air updates. The first use case implements a platform for secure and trackable data sharing between aviation companies, manufacturers, and relevant regulation bodies and other organizations. The main goal is to enable predictive maintenance driven by artificial intelligence and machine learning on top of shared data. Key performance indicators include the increase in trustworthiness of container orchestration for multi-party computation and increase in the efficiency of the operations with federated AI and machine learning orchestration for large consortia and large data sets. The second use case aims to provide to enable confidential computing in the form of a defined platform that can be easily applied in telecom clouds. Key performance indicators include, for example, the simplification of deploying confidential virtual machines and enabling Kubernetes support for confidential containers. Finally, the third use case will provide mission-critical services in the context of secure vehicle-to-infrastructure communications and over-the-air vehicle system updates with distributed learning. The aim is to showcase artificial intelligence and machine learning based on data shared among vehicles and roadside infrastructure to enhance road safety and driving experiences by supporting driving decision-making. Key performance indicators in this case include the trustworthiness of the vehicle's digital identity with the usage of hardware security modules to embed on-chip identities, as well as efficiency and scalability of privacy-preserving communications. Thank you very much for your attention. And if there are any questions, I'll do my best to answer them. Thank you very much.